Thank you, Prof. Thank you for your remarks. Actually, you mentioned a lot of what I was going to say, so I think I don't need to say much more, but for formality's sake, I have prepared a presentation. So as Prof said, my name is Tahmid. I think begin with saying that I'm one of the past students of this place. And I've stuck around from the time I did my undergrad to my master's to my PhD to being part of the family here. There are, just for the students and parents who are here, there are other members of staff. A lot of them are ex-students, and I think I'll keep coming back to that. So if you have any questions, please just put them on the chat. So I've got my team, the marketing team, as well as some of our managerial colleagues who are here, senior members of staff, who can answer those questions that you might have. And also at the end, we will also have a Q&A session. When you come to us at EECE, you'll realize that we are very, very, very interactive. We would like to believe we are friendly and passionate about what we do. So yeah, we would be happy to take your questions and help you explore the possibility of joining our family. So I've got 15 minutes. Thanks to Prof, I've got a few more than my 15. So you'll have to appreciate that as much as I'm going to be giving you what looks like a lecture, this session is not meant to be, as we say, it's not for information exchange as much as it is for excitement exchange. All of us who do this, especially the guys at EECE, are really, really passionate about what we do. We are excited about it, which is why, as you can see, I've stuck around from the time I came here as an undergrad student, and there are a few others here as well like that. So yeah, so my challenge is quite big because the dean mentioned that we are 4 clusters, and our cluster or our discipline is one of the biggest because we are combining electrical, electronic, and computer engineering. So it's quite a bit of a challenge for me to, in 15 minutes, summarize everything that we do. So I'll just give you some highlights in my presentation. So hopefully you'll find it interesting. And if you have any questions, put them on the chat. I will answer them now. So I'm going to share my screen, if you allow me, and I will show the presentation. Okay, so let me try and get this onto full screen. So, so we are the discipline of electrical, electronic, and computer engineering. That's my name. And the dean mentioned it, but we really need to contextualize where we are. And I want to talk a little bit down the history line. Where we speak about where we are in terms of the 4th industrial revolution and how we got here. So the first industrial revolution was categorized or classified by the use of water, steam, and fire power to mechanize production. So that's what made it industrial. Then following on from that, electricity came into play. And so the water, steam, and fire was replaced with electrical power to create mass production, right? To get industry going. Then the 3rd industrial revolution is then where electronics and information came to automate production. And that's what's now led to where we are at the moment. Sorry, there we go, is the 4th industrial revolution. And if you see it from the title of the slide, I said it's the revolutions that are upon us. Because whether we like it or not, this is happening. The digital revolution is something that is going on at neck break speed. And with it, there are other revolutions that are going on because the way we do finance and economics is changing. The way assets as well as services are commoditized is changing and changing very fast. Another part of the revolution is the reality of climate change and environmental revolution because of man's negative contribution to what has happened to our planet, we have to now take stock of how we impact the environment, how we impact the world in which we live in to make it sustainable. And that we are in, as you look around us with all the havoc from a climate point of view, from a pollution point of view, this revolution is part of where we are and part of something we have to consider when we look at and talk about the fourth industrial revolution. The other one is security. Because everything is so digitized, digital, if as much as we come from almost about a year ago where our physical security was in dire straits, soon, as important as that is going to be the security of what we own, because a lot of what we own are going to be digitized. So security of data, security of networks, security, because those things affect our day-to-day life. So for example, if the security of our power grid is compromised, we won't have load shedding, we will have complete blackouts. And because so much of what the fourth industrial revolution is going to digitize the systems that we use around us, security is a huge issue for us to consider. So this revolution, the fourth industrial revolution, is moving at an exponential rate in terms of its velocity, in terms of its scope, and in terms of the systems that it impacts, all across everything that we interact with in our day-to-day lives. It is disrupting every industry in every country of the world. So what the Dean said about being an engineer and being in particular an electronic or electrical or computer engineer, you would be at the forefront of this fourth industrial revolution because it is a digital revolution, right? But just as a preamble, the Dean mentioned, Prof. Bright mentioned that engineers are problem solvers. We're also applied scientists, right? We're also applied mathematicians. So what our tasks in our day-to-day life is to use maths, natural sciences, engineering sciences to solve real-world problems. When I was, I think, in second or third year, one of my lecturers gave me the etymology of the word engineer, and he told me this, so I'm quoting him, that engineer comes from the French word for thinking, to solve problems using your intellectual and analytical capabilities and your knowledge of math science and engineering sciences. So as a summary of this part of my presentation, the choice that we have, because of the waves of revolution that are upon us, is whether you want to be an active, innovative producer or driver of the revolution, or do you want to be a passive, excuse my political incorrectness, dull consumer or passenger in the revolution that is upon us, right? So that is what we want to make you think about and answer this evening as we now unpack some of, well, we are discipline consisting of 3 programs. I've got 2 slides per program, and you'll have to forgive me. Maybe it's a bit dense, but I think I'm not even doing justice to the program. So I'll start with electrical engineers or electrical engineering. People who are electrical engineers are involved in the generation, conversion, storage, and transmission. Sorry, let me get that right. Generation, conversion, storage, transmission, and distribution of electricity from the source to us, the consumers. They're responsible for the development, maintenance, and utilization of the largest man-made machines in the world. As an electronic and computer engineer, I would like to dispute that because we would argue that the internet is one of the largest man-made machines in the world, but that's a debate for us to have in-house. They're both big machines, right? The one on the electrical side is the electrical power grid. And a lot of the research that's going on in the field of electrical engineering is making those grids, which have been around for over 100 years, into smart grids, thanks to the smart capabilities that come from the other disciplines of electronic and computer engineering as well. So a lot of what we present is actually, we are a team, and there's a lot of cross pollination of the technologies that are that are within the three programs. And then the other important part of it is the dealing with the environmental revolution that I mentioned. So we are driving the revolution from fossil fuels based generation, so coal, petrol, right, to renewable generation and green energy. So there we're talking about solar, we're talking about wind, and all the complexities that come around from that. So other countries are far more advanced. Places in Europe, such as Germany, have huge or much greater penetration of renewable energy. I can give you, Germany is a good example, because they really are into solar energy with a fraction of the sun that South Africa has, and yet we are behind them. So in that regard, there's a lot of work for us to do in our content. So electrical engineers are also involved in manufacturing through automation, robotics, in fields of specializations in electrical machine design, power electronics, converters, drives, also control. So you see the pictures on the bottom left there of robots controlling robots. So electrical engineers are dealing with these big scale manufacturing robots, the control algorithms, the control systems for implementing those things. I worked in the south of Durban for Toyota for a year, and I got to program these robots to do things as this image is showing. Furthermore, they're also drivers of PV, which is photovoltaic, and electric vehicle technology. So one of the biggest companies, one of the richest men in the world, is our South African-born Elon Musk, and that's one of his products from his companies, which is making him so rich. That is a technology that is going to be part of the fourth industrial revolution. And further to that, another cutting-edge technology is superconductivity, which we actually have quite a strong presence in this country in terms of research and development for its application to power systems. So those are the two slides for electrical. Now moving on to electronic. This engineering field is a driving force behind the all-pervasive discipline of electronic information handling from analog to digital. So we're talking about information. So TV these days is moving from analog to digital. The sensing world is taking information from the analog to the digital world. But at its core, the electronic engineering discipline is devoted to the understanding and the application of semiconductor physics. They focus on the use, design, and application of electronic systems. So they would be developing new components, designing circuitry, and creating electronic systems for solving real-world problems such as security, surveillance, automation, etc., etc. So it's quite a vast field, and I cannot list the entire field. Just so you know, my degrees are actually in electronic engineering, even though I am housed in computer engineering. And that's because of where I then specialize with my postgraduate degrees. So the topics within electronic engineering, there's a lot of cross-pollination, as I said, and as an electronic engineer, you could be doing computer engineering and vice versa. But topics in electronic engineering include analog electronics, digital electronics, microelectronics, embedded systems. Telecommunications is a huge aspect of our program. Much of our cutting-edge research is done in telecommunications. We've got research funding from Telkom, from Siemens, Nokia, and actually our research group is this year celebrating 25 years of contributing to cutting-edge research in telecommunications. Then furthermore, electromagnetics, automation and control systems, signals and signal processing are topics under the area or under the program of electronic engineering. So just to talk a little bit on the images that you see, the one is on comms, right, and communications. There you see is the backhaul communications. the last mile communications that is making right now. I'm speaking to you from a wireless connection to an access point in my office. I could be instead in the middle of nowhere and instead connecting via the satellite network. Those who are interested, you can look it up. The Iridium satellite network covers the entire planet with network connectivity, and these are the advanced communication systems that we study in this field of electronic engineering in our discipline. Then computer engineering, which is where I call my home. And obviously you might sense a bias as I say computer engineering is at the core of the digital revolution of the fourth industrial revolution. The vision that we have, the vision of the future, is that of advanced fixed and mobile computing systems, from something that could be in the at the size of your top of your finger, all the way to massive devices and drones, driving the revolution with unprecedented processing, storage, and network capabilities. So we're thinking of billions and billions of devices and people being connected. And the idea is this machine, right? I'm arguing the machine of the Internet of Things will improve the lives of people through the use of big data, artificial intelligence, IoT. It is a thing that's been around for a long time, but it's being coined now as the Internet of Things, where anything that is on this part of this digital revolution will be connected to this network. On top of that, there's robotics, autonomous vehicles, virtual assistants, advanced software. So all the cool gizmo gadgets that are really going to be part of the world in the future, that's really upon us in the present, computer engineers get their hands into. So we're arguing that instead of being a passive consumer of all these high-tech products that make our life exciting, what we're saying is you can be an active innovator of the technologies that turns this vision into a reality. You can be part of it and not, you can be part of driving it as opposed to just being a passenger, as my introductory slides mentioned. It is a constantly advancing curriculum, and what we say is we are not necessarily teaching you, but we're teaching you how to learn. Right? So we are not making you learn, we're making you being experts on how to learn, because the field is changing so quickly. And so some of the areas that are involved: design and development of complex computer systems, right, from the smallest scale to the largest scale. Computer and high-speed data networks is part of computer engineering. Machine learning, deep learning, data science aspects. These are all aspects of artificial intelligence, which is a cutting-edge field that is affecting many, many parts of our life. And some of it you might know, some of it you might not know. Then real-time and parallel computing, image processing, and computer vision, with all the surveillance and security that such surveillance gives you. That is all a huge part of computer engineering. Then advanced software engineering, then network security, I mentioned that's a very important part. And then the economic and finance revolution I mentioned, where everything is going to be made into a utility given a price. And so just as we speak about the industrial revolution, right, first, second, third, and fourth, the internet that we use is going through its phases. So we've had Internet 1.0, 2.0, and right now we are actually at the cusp of Internet 3.0. So you might know about cryptocurrencies, which has sort of come in and out of fashion, and people find it controversial. But Internet 3.0 will have at its core the technologies that developed those cryptocurrencies, not for all of that dodgy trading business, if some people find it so, but on how the internet is going to evolve into as we go into the future. So that's sort of in a summary what computer engineering is about. And just as a parting shot, because my time is up, the Dean mentioned some of these things, so I'm just going to summarize again. The EECE at UKZN is in one of the best engineering schools in the country. Our research output is one of the highest in the country. I'm talking about EECE itself. As the Dean mentioned, it is home to a large number of well-equipped laboratories and research spaces. All three of our programs are accredited by the Engineering Council of South Africa, which then makes you eligible for EECCE's highest category of professional registration, and that's internationally recognized by the Washington Accord. So that gives you the title of PREng as a professional engineer, which then makes you a global citizen. And I can, so that you will be able to practice and stretch your legs beyond these shores to places such as Canada, US, UK, Australia, New Zealand, and Europe. So you can secure top level employment both locally and internationally. And in my last slide, I just try to give you from the top of my head. This took me about 10 minutes to do. And every one of these logos that you see are companies where I know someone. I personally know someone who is an UKZN student or an alumni where they call home. So as I was mentioning, quite a number of our colleagues are members of my team and in the marketing team of EECE are actually ex-UKZN students. We have students at of ex-students who are also senior lecturers, senior members of staff at universities such as UCT. There's Toyota, BMW, Eskom, Telkom, Siemens, Transnet, Vodacom, MTN, Internet Solutions. A lot of our research has been in the military industrial complex. So you've got companies such as Reutech Communications. We've got students or ex-students of ours at Denel. One company at the bottom, A2D24, is actually a startup company of ex-UKZN students. Then we've got people in Ericsson. And the other thing I would like to point out is you can see that there are some non-engineering firms here. We've got students at Amazon. That's a huge company competing with Elon for being one of the biggest companies in the world. But you see that there's companies such as ABSA and FNB and KPMG. And this points to the fact that engineers, by your qualification, you are problem solvers, right? And that problem solving does not have to be in relation to just engineering. Although a lot of the students who are in KPMG, FNB, and ABSA are solving some of their tech problems, but engineers are also found in consultancy companies because of our ability to be analytical and real world problem solvers. So this just gives you a snapshot of, to summarize where we've come from, where we are, and where the future holds. So in a nutshell, or as a parting shot, I reiterate, the wave of technological advancement is on us. And what we are arguing for is for you to consider joining our family, because that will put you in the forefront of that wave to ride it as an innovator, as a producer, as someone who's at the cutting edge of it. So now following on from me, so that's the end of my slides. I'd like to just hand you over to Dr. Andrew Swanson. So Andrew is a member of the Center for Power and Energy Systems, and he is also, more importantly, for tonight's discussion, he's been the manager of one of our flagship projects, not the only one, but the one that I think you guys will be most excited by because it's got robots, and we love robots. So he's been the manager of the power line inspection robots, which is a project that's been running in our discipline, and it's multidisciplinary, that has aspects of electrical, electronic, and computer engineering for over 10 years now. So I'll hand you over to Andrew, after which we will also have one of our ex-students. I'll introduce him once Andrew's finished, and then one of our other colleagues, Dr. Mohammed Fayaz Khan, will then sum up. So with that, I now thank you for your attention. Hopefully I haven't bored you, and I managed to share some of my excitement as to what I do. And I'll hand you over to Andrew for the video and his talk. Thank you so much.
Thanks, Tahmid. So while